Please put your attendance in the comment window. In the previous class, we have discussed the first part of module 5, that is column and stress. In stret, all structural elements will be in horizontal or inclined or vertical direction. For a column, it's purely vertical direction. When comparing with stret and column, the difference is cross-sectional area. For a stret, the cross-sectional area is less, but in the case of a column, the cross-sectional area is high. So automatically, the column can carry very heavy compressive load, but a stret cannot carry high compressive load. ഇത്രയാണ് അതിന്റെ difference. Okay. Then we have discussed different type of end sections, that is both ends are hinged, one end hinged, one end fixed, then both ends fixed, and last one is one end fixed and other end free. And effective length also we have studied in previous class, and also slenderness ratio. These are the things we have studied in the previous class. So today we are going to discuss Euler's equation or Euler's formula for long columns. It's purely for long columns. As we have already discussed, long columns are failed due to crippling or buckling load. So we are going to study that area. For that, first of all, we must know Euler's theory. The column and strut which fails by buckling may be analyzed using Euler's theory. So first of all, you must write some assumptions of Euler's theory. It's very important. So please write down following assumptions. That include the column is initially straight. Second one, the cross section is uniform throughout. And third one, the line of thrust coincides exactly with the axis of column. And the material is homogeneous and isotropic. Shortening of column due to axial compression is negligible. These are the assumptions we are considering while deriving Euler's theory. So first of all, you have to write the heading Euler's theory. Please write down Euler's theory. Subhead the columns and strut. The columns and strut which fails by buckling. The columns and struts which fails by buckling. Which fails by buckling may be analyzed by Euler's theory. May be analyzed by Euler's theory. Following are the assumptions. അതല്ലെങ്കിൽ താഴെ assumptions. Assumptions of Euler's theory. എന്ത് വേണമെങ്കിൽ എഴുതാം? Assumptions എന്ന് എഴുതുക. താഴെ ഓരോ പോയിന്റ് എഴുതുക. First point. The column is initially straight. 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 Second one, the cross section is uniform throughout. The cross section is uniform throughout. The cross section is uniform throughout. Third one, the line of thrust coincides exactly with the axis of column. The line of thrust, the line of thrust coincides exactly with axis of column. Exactly with axis of column. Exactly with axis of column. Next point, the material is homogeneous and isotropic. The material is homogeneous and isotropic. The material is homogeneous and isotropic. And last assumption, the shortening of the column due to axial compression, shortening of column due to axial compression is negligible. The shortening of column due to axial compression is negligible. The shortening of column due to axial compression is negligible. These are the assumptions made for deriving Euler's equation. And while doing such thing, we need to know what is the sign conversion. It's very important. Don't misunderstand with previous examples. For a column, when we are taking a long column, we must be very careful whether that is positive or negative. If a structural member is AB, that is subjected to the force P at P as well as at A, that is compressive load, that will bend like convexity or concavity. In most of the case, on 99% of the case, that will be concavity. So the momentum generated always will be negative. But in the case of one end fixed and other end free, we have an equation for one end fixed and other end free. Such thing will be bent like convexity. But both ends are hinged means or fixed means the internal bulge will be concavity, that is negative. Please note down the sign convention. If the from the axis, if that is possessing outward, that is convex type, that is positive. If from the axis that bulge as concave, that is known as concavity, that is negative. Please draw down. Can I change the slide? Hope you have drawn. Have you drawn? We have very less time with us, so please draw fastly. The derivation of Euler's equation is very simple one. So when you are studying that thing, please note down each and every point. That will help you to score high marks. Comparing with all other derivations like Macaulay's, everything, it's very simple derivation. In the question paper on in the syllabus, they have mentioned only to derive Euler's equation for both ends pinched or pinned or hinged. So no need to take other end conditions. Only you need to derive equation for both ends pinned. Hope you have drawn. I am going to the next slide. I am taking a case this was discussing in your syllabus, which should be derived for this theme, that is both and hinged. This is also will ask as both and pinned, pinned. Consider a beam that is OA. Here you can see O is here and this is A. Actually, I misunderstood the words. This will be A and this will be B, I think. Sorry, 1 minute. Yes, there's a mistake. This is B actually, and this is A. Consider നിങ്ങൾ വരക്കുമ്പോൾ ശ്രദ്ധിക്കണേ വൺ ബീം വിത്ത് നേരത്തെ പറഞ്ഞ ഇതേ ഫിഗർ എടുക്കുക എ ബി എന്നുള്ള വിധത്തിലാണ് ഉണ്ടാവുക ഇതുപോലെ ഉണ്ടാവുക എ അറ്റ് ബോട്ടം ബി അറ്റ് ടോപ്പ് both are hinged and applying a force of P at A as well as B that is bulging in a concave direction. You can see this is a concave direction and length of the beam, that is length of the column, will be L. And if we consider this length as X and the deflection at that X distance will be Y, just check this one because in normal cases we will draw y as vertical line and x as horizontal line, but for a column we will consider vertical axis, that is axis of column as x axis and horizontal direction as y. So all points should be very carefully marked. A B is the beam or column and length of the column is L, and we consider a point at a distance x where deflection is marked as small y. There is a force, compressive force, capital P, and both ends, and the structural element bulge in a concave form. So definitely you can say what is the moment. We have general equation for moment as EI d square y by dx square, or in this case we have force into perpendicular distance. If we consider this is the force P and perpendicular distance is y. So force will be P into y. Since it's a concave action, the sign will be minus. Please draw only this figure and mark this equation. Please inform why after completion of your drawing. Have you drawn this one? Hello? Please respond. If you had any queries, you can ask now. Arjun,
Yes,
others,
sir.
have you drawn this one?
Yes, sir.
Yeah.
Okay, okay. After drawing, please write down Consider a long column. Consider a long column. Consider a long column AB. Consider a long column AB. Consider a long column AB having a length of small l, having a length of small l, having a length of small l, is applied by a compressive force, having a length of small l, is applied with a compressive load P, is applied with a compressive load P, is applied with a compressive load P at the hinges A and B. A and B. Let small letter y, let small letter y be the deflection, small letter y be the deflection of the long column at a distance small x, at a distance small x, at a distance small x, at a distance small x from hinge A, at a distance small x from hinge A. We have general equation of bending moment. General equation. എങ്ങനെ? Can you repeat?
സ്മോൾ എക്സ് അല്ല പറഞ്ഞേ?
സ്മോൾ എക്സ്.
അവിടെ
സ്മോൾ എക്സ് അല്ല, മോളിലാണ് വലിയൊരു ക്യാപിറ്റൽ എക്സ്. ഞാൻ ഇവിടെ മാർക്ക് ചെയ്തതാ. ഇത് ക്യാപിറ്റൽ എക്സ് ആണ്, അതുകൊണ്ട് ഇത് സ്മോൾ എക്സ് ആയിട്ട് കൊടുക്കുക. എനിക്കത് സ്മോൾ എക്സ് ആയിട്ട് കാണിക്കാൻ പറ്റാത്തതുകൊണ്ട് ഇത് സ്മോൾ എക്സ് ആണ് കേട്ടോ. ക്യാപിറ്റൽ എക്സ് ആക്സിസ്, ക്യാപിറ്റൽ വൈയും ആക്സിസ്, ഡിഫ്ലക്ഷൻ സ്മോൾ വൈ. ഇവിടെയുള്ള ഈ ഡിസ്റ്റൻസ് ഇവിടെ സ്മോൾ എക്സ് അല്ലേ?
അല്ല, ഡിസ്റ്റൻസ് എക്സ് ഫ്രം എ ആവണ്ടേ?
ക്യാപിറ്റൽ എ. ഞാൻ ആക്ച്വലി ഇത് എയും ഇപ്പുറത്തെ സൈഡിൽ ബി ആണ് വേണ്ടതെന്ന് പറഞ്ഞിട്ടുണ്ടായിരുന്നു. ഓ അല്ല, ഇത് എ, ഇവിടെ ബി ആണ് വേണ്ടത്. കാരണം അത് നോർമലി നമ്മൾ എയും ബിയും ആണ് കൊടുക്കാറ്. അങ്ങനെ പെട്ടെന്ന് ഓ കൊടുക്കുമ്പോൾ, അങ്ങനെയാണെങ്കിൽ ഇതേ ഫിഗർ വെച്ചിട്ട് ഓ ആ മാർക്ക് ചെയ്തിരിക്കുന്നതെങ്കിൽ യു ഹാവ് ടു റൈറ്റ് ഫ്രം ഓ എന്ന് കൊടുക്കണേ. ഓക്കെ, നോ ഇഷ്യൂസ്. അത് എങ്ങനെയായാലും കുഴപ്പമില്ല. അത് പക്ഷേങ്കിൽ എല്ലാവരും ഒരുപോലെ എഴുതണം എന്നുള്ളതുകൊണ്ടാണ് ഞാൻ എയും ബിയും പറഞ്ഞത്. ഞാൻ മാർക്ക് ചെയ്തപ്പോൾ ഇവിടെ ഓ ആയിപ്പോയി. പെട്ടെന്ന് ആക്കുന്നില്ലടാ. രാവിലത്തെ ക്ലാസ് കഴിഞ്ഞ് ഇപ്പോഴത്തെ ക്ലാസ് ആകുമ്പോഴേക്ക് ആക്കണ്ട. അതിന്റെ ഇടയിൽ വേറെ ക്ലാസ് ഉണ്ട്. സോ മിസ്റ്റേക്ക്. ഓക്കെ എന്നാ ഫ്രം ബി എന്ന് എഴുതിയാൽ മതി. നോ ഇഷ്യൂ. പക്ഷേങ്കിൽ എ താഴെയും ബി മുകളിലും കൊടുക്കുന്നതായിരിക്കും നല്ലത്. അതുകൊണ്ടാണ് ദാറ്റ്സ് വൈ ദിസ് ഈസ് ദ ഫിഗർ. എ അറ്റ് ദ ബോട്ടം, ബി അറ്റ് ദ ടോപ്പ്. Okay. So general equation of bending moment is given as EI d square y divided by dx square. EI d square y divided by dx square. From the figure, that is ഇപ്പം വരച്ചിരിക്കുന്ന figure. From the figure, We have bending moment from the figure. We have bending moment M is equal to, from the figure, we have bending moment M is equal to force into perpendicular distance. അതായത് എന്തായിരിക്കും മൈനസ് പി വൈ. അത് മാത്രം എഴുതിയാൽ മതി. M is equal to മൈനസ് പി വൈ. M is equal to minus py. So we have an equation that is ei d square y by dx square equal to M is equal to minus py. This equation is already written. From here you can take ei to the right hand side. So the equation will become d square y by dx square equal to minus p divided by ei into y. This is the common equation. And if we take this one to the left hand side, the equation will become d square y by dx square plus p divided by ei into y equal to 0. Or ഈ p divided by ei എന്നുള്ളത് ഞാൻ കോമൺ ആയിട്ട് ആൽഫ സ്ക്വയറിന് കൊടുക്കുവാണ്. ഓക്കെ, ആൽഫ സ്ക്വയറിന് കൊടുക്കുവാണെങ്കിൽ ഓട്ടോമാറ്റിക്കലി ഇതിനെ ലെഫ്റ്റ് സൈഡിലേക്ക് എടുത്തു കഴിഞ്ഞാൽ വി ക്യാൻ റൈറ്റ് d square y by dx square plus alpha square y equal to 0. This equation can be written as like this, where alpha square is equal to p divided by ei. Alpha square is equal to p divided by ei. Someone will have confusion that why alpha square. Actually, to get the final equation, we are in need of alpha square. So constant can be taken any time, any style, but for Euler's equation, that's taken as alpha square. So now you need to solve this equation. For solving this equation, we have a sinusoidal equation. You know that if we have this kind of equation, we can solve it using a constant like this. This will be the solution of this one. That is d square y by dx square plus alpha square y equal to 0. If we are solving this equation, we will get an homogeneous equation as y is equal to a into sine alpha x plus b into cos alpha x, where a and b are constants, not these points. Don't compare with this one. Any points can be that one. This can be written as constant a into sine alpha x plus constant b into cos alpha x. ഇതൊരു കോമൺ ഇക്വേഷൻ ആണ്. ഒരു ഇതുപോലുള്ള ഒരു ഡിഫറൻഷ്യൽ ഇക്വേഷൻ സോൾവ് ചെയ്താൽ നമുക്ക് കിട്ടുക അതിന്റെ കോസ് ആൻഡ് സൈൻ ടേംസിലാണ്. സോ the solution will be y is equal to a sine alpha x plus b cos alpha x. So please write down all these points, how that is coming to this one. In every conditions, when we are deriving an equation, first of all, we need to find out the equation, and after that, you need to give the boundary conditions. Till now, we have derived the equation that is ei d square y by dx square equal to minus py, where ei is taken to the right hand side. That means d square y by dx square is equal to minus p divided by ei into y. And if we substitute p divided by ei as alpha square, we will get d square y by dx square is equal to minus alpha square y. And taking this term to the left hand side, the equation will become d square y by dx square plus alpha square y equal to 0. So when solving this equation, that's in differential form, that is d square y by dx square plus alpha square y equal to 0, we will get a solution as a into sine alpha x plus b into cos alpha x. This is an important equation. And after that, we need to give the boundary conditions. When we are giving boundary conditions, just look here. When x equal to 0, that's this point, that is a point. Here, there will not be any deflection. So, y is equal to 0 at x equal to 0. Similarly, when we are taking x equal to L, this point, another point, this is also hinged point. There will not be any deflection. So, such case that will be L. When x equal to L, y equal to 0. That are the two boundary conditions. That is when x equal to 0, y equal to 0. When x equal to L, y equal to 0. So substituting these values in the previous equation, that is solution, you will get y equal to 0. First condition കൊടുത്തു കഴിഞ്ഞാൽ y equal to 0. A into sine alpha 0. That is sine 0 will come. This all term will become 0. Okay, plus b into cos alpha x means cos 0 is equal to 1. That is 1 into b equal to y എന്ന് വരും. So b should be 0. At least b should be 0 കൊടുത്താൽ മാത്രമേ നമുക്ക് ഈ equation stable ആയി കിട്ടുള്ളൂ. So from this equation, applying this boundary condition, we will get b is equal to 0. Similarly, the second boundary condition, when x equal to L, y equal to 0. So y will become 0. A into a sine alpha L plus b is already found as 0. So substituting 0 into cos into alpha L, this all term will become 0. So 0 is equal to a into sine alpha x. When comparing these relations, you can see that a sine alpha L should be 0. But if we put a as 0, already we have b as 0. In all cases, we will get deflection as 0. But it is not possible because you can see in intermediate points, when coming to this point, there is a deflection y. So we cannot put a as 0. So y will become 0 and there will not be any bending. So we cannot take a as 0. So we have to substitute sine alpha L as 0 or alpha L as pi. That is, we know that sine alpha L becomes 0 only at the point 0, pi, 2 pi, 3 pi, likewise. But we cannot substitute length as 0. So we have to take the least value, that is pi. When substituting sine alpha L equal to 0, we will get alpha L as pi or alpha as pi by L. Okay, this value should be substituted in this equation. That is alpha square is equal to p by ei. That is p will become alpha square into ei. That is here p will become alpha square into ei. Substituting alpha square as pi by L whole square. That is pi square divided by L square. The final equation will become pe is equal to pi square ei divided by L square. This is the derivation, very simple derivation. So understand carefully, and if you have any queries, you can ask now. Please write down. Apply boundary condition. ഇതുവരെ നമ്മൾ എഴുതി തോന്നുന്നു. So after that, what are they? Please write down. In the K2 syllabus, they have only asked you to solve or derive equation for both and hinged or both and pinned. So this is the derivation formula. For other things also, you can derive in the same manner, but that is not required in your syllabus. So when you are doing such thing, you can find that this L value only will be varying. And we have to write. Have you completed this one?
Sir, ഒരു മിനിറ്റ്.
Okay, first.
സാറേ കഴിഞ്ഞു.
Okay. So Euler's formula for all the problems. We have, if whatever problem, we can write it as PE is equal to pi square EI divided by LE square. Here L is replaced by effective length. You should write this equation and mark it as effective length. No need of writing all these things. This is for your reference only. Effective length we have already taken in the previous classroom. And have you written this equation? There is no change with the previous one, only L is changing to LE, where LE is the effective length. So, first of all, we must know what is LE. As we have already written all these things, no need to write again and again. I will mention if both ends are hinged, LE will become L. That is here. LE is equal to L. This is the equation which we have derived now. And 1 and fixed and 1 and free means that will become LE is equal to 2L. So this length will become 2L. And if both ends are fixed, LE will become L by 2. LE will become L by 2. If one end fixed and other end is hinged, then the equation will become 1 by L by root 2 or 0.7 L. We have mentioned it as 0.7 L. That's equal to നേരത്തെ വരച്ച ചിത്രത്തിൽ equal to L by root 2 എന്ന് കൂടി എഴുതി വെച്ചോ, കാരണം പെട്ടെന്ന് മനസ്സിലാവാൻ. ഇതാണ് നമ്മൾ ഇനി ഉപയോഗിക്കാൻ പോകുന്ന ഇക്വേഷൻ L by root 2. വീണ്ടും വരക്കണ്ട, നേരത്തെ വരച്ച ഫിഗർ ഉണ്ട്, അതിൻ്റെ അകത്ത് മാർക്ക് ചെയ്താൽ മതി. ദിസ് ഇസ് എ സിമ്പിൾ ഫിഗർ. ഇങ്ങനെ വരക്കാനാണ് ഞാൻ നേരത്തെ പറഞ്ഞത്. എത്ര പേര് ഓട്ടോമാറ്റിക്കലി വരക്കും എന്നുള്ളത് മനസ്സിലാക്കാനും കൂടിയാണ്. Okay, so we have n conditions as like this: both end hinged, one end fixed and one end free, both end fixed, and one end fixed and other end hinged. In all cases, we have equations as here. You can see crippling load will become pi square EI divided by L square. Pi square EI divided by L square. Or you can write, no need of writing these terms. Actually, this is best. Crippling load, you can write like this. No need of writing all these things. Both are same. Actually, here there is no change. Equivalent length is L equal to small l. In second case, pi square EI divided by 2 into small l square, where capital L is LE actually. We can write LE square everywhere, but LE equal to 2L. When you are substituting that 2L here, you will get 2L square. That is for L square. And when you are substituting L by 2, you can get the equation as L by 2 all square. And that can be taken top side, that is 4 pi square EI by L square. And when you are substituting LES L by root 2, we will get LES L by root 2 square. Root 2 square will become 2. So final answer will be 2 into pi square EI divided by L square. Please make it as a box. Please make it as a box. Have you completed? Have you completed? May I go to next slide? Hope you have completed. I'm going to the next slide. It's very important that some limitations are there for Euler's formula, and we have already discussed some Euler's formula. In that Euler's formula, what are the limitations? Where we cannot use this Euler's formula is discussing here. First one is Euler's equation is not applicable for short and intermediate column. That is medium column. That is Euler's formula is not applicable for short column and medium column. Please write down. Limitation of Euler's formula. Euler's equation is not applicable for short and medium column. Euler's equation is not applicable for short and intermediate column അല്ലെങ്കിൽ medium column. Euler's equation is not applicable for short and medium column. Second point, it is not applicable for eccentric loading. It is not applicable for eccentric loading. It is not applicable for eccentric loading. നിങ്ങൾക്കറിയാം നേരത്തെ നമ്മൾ P അപ്ലൈ ചെയ്തിരിക്കുന്നത് നേരെ സെന്റർ പോയിന്റിലാണ്. So it cannot be used if there is a eccentric load on the column. We cannot use Euler's formula. For that we are using Rankine's equation. So next point is for a long column with limiting values of slenderness ratio. For a long column with limiting values of slenderness ratio. For a long column with limiting value of slenderness ratio. For a long column with limiting value of slenderness ratio, the compressive stress due to the compressive stress due to direct load will be considerable. Direct load will be considerable and hence sum of stresses due to crippling load and stress due to direct load may exceed crushing stress. ഇത്രയാണ് ഇപ്പോൾ നമുക്ക് എടുക്കുന്നത്. അടുത്ത കുറച്ച് ഇക്വലിബ്രിയം കണ്ടീഷൻസ് ഉണ്ടായിരുന്നു. ഞാൻ അസൈൻമെന്റ് തരാൻ പോകുന്നതാണ്. കോഴ്സ് മെറ്റീരിയൽസ് അപ്ലോഡ് ചെയ്യുമ്പോൾ ഉണ്ടാവും. എന്താണ് സ്റ്റേബിൾ ഇക്വലിബ്രിയം, അതേപോലെ തന്നെ എന്താണ് ന്യൂട്രൽ ഇക്വലിബ്രിയം, അതേപോലെ തന്നെ എന്താണ് അൺസ്റ്റേബിൾ ഇക്വലിബ്രിയം. ഇതുമായിട്ട് ബന്ധപ്പെട്ട ഒരു പ്രോബ്ലം ചെയ്യാനുണ്ട്. ആ പ്രോബ്ലം നമുക്ക് കംപ്ലീറ്റ് ആക്കാം. ഇപ്പം അല്ല, അടുത്ത ക്ലാസ്സുകൾ വരുന്ന സമയത്ത് റാങ്കിൻസ് കൂടി കഴിഞ്ഞിട്ട് യൂളേഴ്സിന്റെ റാങ്കിന്റെ പ്രോബ്ലംസ് നമുക്ക് ഒന്നിച്ച് കംപ്ലീറ്റ് ആക്കാം. താങ്ക് യു ഫോർ ലിസണിങ്. ഒന്ന് അറ്റൻഡൻസ് എല്ലാവരും പറയണം. Please put your attendance and leave the call.